Hello guys out there, this is Promise from Learn Python. In this video, we're going to talk on an interesting topic called recursion. Recursion is a function that calls itself a number of times to perform an operation. Now, in programming, there are some times you want to solve algorithms, coding challenge, and those scenarios you want to use recursion. So in this video, we're going to learn how to use recursion properly and how you understand them and use them to solve those particular problems and algorithms. Now we have an example here. We have a little example here, little function. We are adding one to a function, so we'll call the function add one. So we pass in a parameter n. So we are checking if this n is equal to 2, then we return that value n. Anytime this n becomes 2, we are going to return the value. So now we are going to add 1 to the end, which is the reason for creating a function. So we are adding 1. So we return the added function. Then we call this function again. We call it so that we can increment 1. So now we print the final return statement, what we return from the final, what this statement return here. So we'll pass in 1 as a parameter. So when we run this function, I ran it before I started the video. So when we run this function, you get to as your final output. Now let's take a look at what is going on deeply in the function. So in this function, we pass in 1 as our parameter. So when we get here at the top, n is equal to 1. So we check if is n equals to 1. No, n is not equal to 1. So we are not returning anything here. So now we are going to add 1 to n. So now n becomes 2. So we pass n into the function. Then it comes back. Is n equals to 1? No, n is equal to 2. So we return n. So the function stops executing. When we return n, this function comes back to this line and return the final output, just like storing the value and returning the output from this add. Since this add 1 has stopped running, so we return the final output of this add 1, so it becomes 2. So just know that anything you return here will be returned in this function. So whatever this function return, whatever this n return here, it's going to return 7. So that will automatically be returned here. So anything returned here will be printed as a final output. So if we run it now, we'll get 7 our output. So in this case, we don't want to return 7, so we want to add 1 to a number, so we return n. So let's go further and take a look at what is really going on inside our recursion. So what is the base condition in a recursion? So I just quickly term it as the terminal condition, like where you want when do you want your function to stop running? Like this is the terminal condition. So like this if statement here, if your if statement here is not in your function, it won't your recursion won't work because it needs the terminal point to stop working. If not, it just throws an error. So that's one way. But another reason why you need your terminal condition is to return your smaller solution to your function so that it gets passed into the let me call it the bigger function now, or the top function. So anything your terminal return statement gave you, then that will pass up to your return function. So that will get printed out in your console. So now let's look at this function before we print what's going on here. Now we pass in 1 as a parameter. So we are checking if n is equal to 2, return 1. Now look at here, we are returning 1 in this case. So we are adding 1. Let's forget about this return statement now since n is not equal to 2 yet. So we are adding 1 to n. So now n is equal to 2. Now since n is equals to 2, we'll come to this terminal statement. So this function is going to return 1. So at the top of this function, we have 1 here and we have 1 here. So it means we are going to have 1 plus 1. Since n is equals to 2, we are going to have 1 plus 1. So our final output is supposed to be 2. So we'll just know that any 2 we are returning here will get passed up to the top. So if we return 2 here, we're going to have 2 plus 2, 4. So any 2 you are returning as your terminal output. If you return 6, for example, you're going to be getting 12. So that's just a simple way to explain what's going on in this place. So now let's see how we can use recursion to solve a real life example. Let's use recursion to find factorial for a particular number. So you can see I just have an example here using recursion to find factorial for a number. For example, 5. So I created a factorial function. Now we are checking if n is equals to 1, we return 1. Remember that's the terminal condition. So now return n times factorial n minus 1. What are we doing here? Now we are subtracting n anytime we are passing n into this factorial function. Now what is happening here? We introduce a variable. In our previous example, we never introduced a variable, but now I'm going to explain what this thing is what is happening here. Now this variable gets stored in memory. Initially n becomes 5 at the first instance. Let me come down here. At the first instance, n is 5. N equals to 5. At the second instance, when you subtract 1 from n becomes 4. N becomes 4. And so on until it gets to 1 at your terminal statement. So your last value, so this n multiply itself with 4, multiply itself with 3, 2, then when it becomes 1, also multiply itself with 1. So if we take a look at this output, we see that we actually get the factorial of 120, of 5 to be 120. So now I want to explain a little thing what's really going on here. So we can actually comment this stuff and see what I was trying to explain to you. So you can take a look at the console and see what's happening to the value of n before the factorial will be printed. So initially n is 5. Wait, I got an error. Come. Okay, time is not defined. Let me quickly import time in this function. Sorry about that. Okay, I run the function again. Now initially n will be 5, then 4, 3, 2, then 1. So n does all the operation. So now when n is 5, 4, 3, 2, 1, is adding, like n is kept there, another n is kept at the side. It means 5 times 4, then times 3 times 2, then the last value times 1. So we are going to multiply all the values. If I've been saying addition, sorry, is multiplication. So we are going to multiply all the values together to get your final output. So this is just a way to test your what's going on in your fraction. So let's look at another example where we use recursion to solve Fibonacci series. So now we can actually get a Fibonacci. Okay, let me explain what a Fibonacci sequence is. Like it's a number where you get the next value is calculated by getting the addition of the previous two values. So the value 1 here is gotten from 0. Okay, this first value here is 1. Yeah, the first value here is 1. So this value 1 is gotten from the first two values. 0, nothing. There is nothing here. 1 plus nothing equals to 1. So now the next value 2 we got it from 1 plus 1, 2. So the next value 3, we got it from 2 plus 1, 3. Next value 5, we got it from 3 plus 2, 5. So now how do we actually take a look at this using recursion? Now we define a Fibonacci function and passing n as a parameter. We came here, we wrote our terminal condition, said if n is equal to 0 or n is equal to 1, we return n. So stick with me, you understand this. Now we return the function called of itself, then add another function called of itself, subtracting 1 and subtracting 2. So if we try to get the Fibonacci number at number 6, like the sixth Fibonacci number, now we are supposed to get 8, if I'm correct. So we are getting 8 here. So now what is really going on in this function? If you understand what I've been saying since, you will really get what's going on. Now we are passing 6. You have to start from the bottom. We are passing 6 to this Fibonacci function. Now we are checking, is n equals to 0 or is n equals to 1? No. Return n if so. Now we are passing n minus 1, then n minus 2. The reason we are checking if n is equal to 0 and n is equal to 1 is because we are subtracting minus 1 and minus 2, because there will be a scenario where n will be equal to 0 and there will also be a scenario where n equals to 1. So are those two possible? Because we are subtracting, so n likely becomes 0. So when n jumps from 2 to 0, so we should have a case for it, then return that number n. So now this is just the terminal point, like the last point. So I think you should be understanding this now. So we are adding the values. In this case, we are adding, it's just like saying the previous number added to the last two numbers to get the next number. So that's just a brief way to explain it. But what is really going on here is that this function is going to the terminal state, then getting the number n at the terminal point, then accumulating it and add it up to 8. So that's what's going on inside this function. So if we check the Fibonacci sequence of another number, let's say 8, at the 8th position we are supposed to get 21. So that's it for that one. So let's take a look at using recursion with list. Now we can also work with list with just a simple idea. I will give you an idea on how to use recursion with list and wrap this video up. So let's assume we want to remove every element from a list. So how do we do that? It's just a brief example. We pass in the array, then check for the length. If the length is equal to 0, we will return. It means if all the elements are removed, we return the list. So we return the empty list. So what do? We return the function, then start clearing every part of the list by starting from the index 1 to the end. So we are removing one value at a time. So we can decide to remove 2. It's better to remove 1 because sometimes if you remove 2, you might get index value error because it won't be up to 2 again. So you remove 1 to be on the safer side. Then when we print the output, we are going to get an empty list. So I feel you should understand this stuff. Now, what is really going on here? We are calling our function here clear. then we are passing this array of 4 digits. So now at the first instance, is the length 0? No, it's not 0. So we pass in a copy of the array, but we are starting from index 1. We are starting from 2. So 2, 4, 5. So the length is 3. So we go to the function. Is the length 0? No. We come here, pass the array again from index 1, which is now 4. So we come here, is the length 0? No, it's 2. So we pass in again, index 1. Is the length 0? No. And then we do it again. Is the length 0? Yes, the length is 0. So we return the array, then we print out the final output. If you want me to test this stuff, I can actually copy this stuff here and test. I think my time should be defined because it's just this page. Let's really check what's going on. I think what can we do? We can print the array, right? In the array and check the length. Yeah, this is going to be, yeah, the previous value we always like. If you wanna like we can actually remove this stuff. We can just remove this one. It won't work well for array, like the visual output. Like, but we get what's going on. Like, okay, now the values have been removed. Like it was 4, then 3, 2, 1, then nothing. Like just like that. So we get the point. So we can comment this out. So let's see now how we can do some advanced stuff a little bit. It's just like you are doing some algorithm tests and you want to they ask you to like get the index of a particular number, not just index, using a negative index to get the index of a particular number, then adding a number to it. You can add any number to the number, return that index, and they ask you to use recursion. It's just an example. So now how do we do that in Python or using recursion? Now we define a function get index and add a number. So we pass in the array, the index and the number we want to add. Then we check. I'll come back to this if statement later, but just check if the length of the array is equal to the index times minus 1. We return the array, the the array of 1, like the 0th element, the first element plus 1, because that's what we want. We want the first element. I'll explain why I want the first element. I want to add the number. So, but you are getting the index of that element. You are trying to get the index of the element, then we add the number. So that's what this stuff is doing. But at the end of the day, when it loops, when the sorry, when the function has finished running or is terminated, the value you are getting will be at the first position because it's actually removing all the initial value, just like what we are that's what we are doing. We are removing the initial value. So the value you be getting will be at the first position. So you then add not the number you want, then you return. So we call the function, then remove the initial values, then pass the index. So the index will never change, the number will never change. So until you get to the terminal point, that's when this index, that's when the number will be added to the value you want, and then that stuff will be returned. So let's run the function. Let's see what's going to happen. So let's see what we wrote here. We wrote print get index and add num. So 2, 3, 4, 5. So we are getting an index of minus 3. So if we count from the back, 5 is minus 1, 4 is minus 2, then 3 is minus 3. So the index of minus 3 is 3. So we are adding the number 3 to it. So hopefully we are going to get 6 as our output. So now we are getting 6 as our output. Now, so what is happening with this if statement here? So we are checking if the length of the array is equal to the index minus 1. So now we pass in an index of 3. So now here we are multiplying the index by minus 1, which means we are converting this index into a positive number, which means that a negative index is equal to the length of the array, like the length of the array when we have removed all the number and that element we want to add stuff to will be at the first position. So when we remove the first element, if this stuff is minus 3, if this position of this element was minus 3, so the length will be minus 3. So if the position of this guy is minus 4, the length will be 4. So I said minus, the length will be minus 3 just now. So the length will be 3, not minus 3. So the length will be 4 when the position of 2 is minus 4. When the position of 4 is minus 2, the length of the array will be 2. So that's what we are doing. That's the little trick we are doing here to just convert the length of the array from the index. We just convert the index of the array to the length by by multiplying minus 1. So hopefully you should know how to tackle recursion. So if you like this content, you can subscribe to Learn Python. It's just a channel trying to grow. So subscription will be helpful to the channel, and you can also leave a like to the video. It also helps us a lot and therefore our video to be shown to more people and more viewers. And once again, thanks for watching. Happy coding.